In this video presentation, we're going to take a close look at the data link layer, which is layer 2 of the OSI model. The data link layer provides access to the networking media and the physical transmission across the media, and this enables the data to locate its intended destination on a network. The data link provides reliable transit of data across a physical link by using the media access control, or the MAC address. The data link layer uses the MAC address to define a hardware or a data link address in order for multiple stations to share the same medium and still uniquely identify each other. So there's two sublayers that make up the data link layer. You have the LLC, which is the logical link control, and then we have the MAC layer. Now the MAC layer is much closer to the physical layer than the LLC. That allows us to have multiple sessions going on with different computers at the same time, but we only need one LLC to control all of it. That's why it's set up that way. Now let's talk a little bit more about the MAC sublayer. So the MAC sublayer carries the physical address of each device on the network. This address is more commonly called a device's MAC address or a physical address. The MAC address is a 48-bit hexadecimal address that's encoded on each network device by its manufacturer. It's the MAC address that the physical layer uses to move data between nodes of the network. So, once the Arp broadcast was done, which is pretty much done at the networking layer, where we went out and we said, who has the following IP address? That IP address responds with its MAC address. That's kept inside of the Arp Cache. Now, what devices use an Arp Cache or use a MAC address to filter with? There's two, and these two devices reside here at the data link layer. They are the bridge and the switch. Okay, very good. Now, what else happens here at the data link layer that's so important? Well, this is where frame encapsulation takes place. This is also where error control and flow control take place. So how does it do this error control? Well, the error control is accomplished with something that's called a CRC, or a cyclic redundancy check. That's a special bit that's put into the data packet as it's sent across the wire. Now, once the packet is received, the receiving unit does its own CRC, cyclic redundancy check. And basically it's just a mathematical computation, and it deciphers what the size of the package actually is. Now the receiving unit compares its CRC with the sender's CRC, and if they're both the same, it's assumed that the packet is intact and that its contents is correct. That's how it does the error control. Now the flow control is where it basically establishes the communication link between the receiver and the sender, and pretty much they talk it out. They basically configure, they actually come up with a way to say how much data they can handle at one time without overflowing the buffer or overflowing the transmission line. And basically when they agree upon the size of this packet, that's what they're going to use, and that's flow control. So all this takes place at the data link layer. So at the data link layer, we basically have the MAC address of the NIC, and that's what actually gets recognized at this layer. So it's right above the physical layer. So as the information comes across the wire and it comes up through the physical layer, the first thing that has to happen is that it has to hit that NIC card. It has to find that MAC address to ensure that it found the correct host, and once it does that, then the LLC takes over. So that's all about layer 2 of the OSI model, the data link layer. In our next presentation, we're going to get up one more layer, and we're going to take a look at the networking layer.